Hi, I'm Sanchit Dhami, a third year student pursuing mechanical engineering from DTU. Today I'm going to give a video presentation on flame propagation and engine variables affecting flame propagation. Firstly, what is flame propagation? It can be expressed in terms of flame speed, which is measured as the rate of propagation of the flame front into an unburned mixture inside the combustion chamber. In an IC engine, the flame speed is a property which determines the ability of the engine to undergo controlled combustion without detonation. It also affects the rate of pressure rise inside the combustion chamber and ultimately affecting the engine performance. Now firstly, let us understand with the help of this image as to how flame speed affects detonation and ultimately the engine performance. As the piston moves from BDC to TDC during the compression stroke, due to spark advancement, flame front begins to advance from point A towards point D in the combustion chamber. As the flame front advances, it compresses the unburnt fuel B-D, raising its temperature. The temperature is also increased by radiation from the advancing flame front as well as the reactions taking place in the unburnt mixture itself. In detonation, the end charge auto-ignites before the flame front is able to reach it. In order to auto-ignite, the last unburnt fuel mixture has to attain a critical temperature and remain at this temperature for a given period of time. This period of time is known as ignition delay. If the flame front reaches B' and the unburned charge B'(D) reaches the critical conditions for autoignition. If the flame propagation is taking place with a sufficiently high speed such that the time taken for the flame to travel from B' to D is less than the critical time, is less than the ignition delay, then no autoignition will take place, thereby preventing detonation and enhancing the engine performance. The flame propagation plays an important and very critical role in terms of engine performance. However, flame propagation and hence flame speed are influenced by several engine variables which are as follows. The first factor affecting flame propagation is air-fuel ratio. A 10% rich air-fuel mixture will have the highest flame velocity, therefore will provide better engine performance and characteristics. However, if the air-fuel mixture becomes too lean, too rich, then incomplete combustion will take place as a result of which the exhaust gases produced such as carbon monoxide etc. will cause retardation of flame propagation, therefore reduction in flame speed. However, at the same time, if the fuel mixture is too lean, then insufficient supply of air is available, as a result of which flame propagation is again retarded. The second factor affect. Now we come to the second factor. The second factor affecting flame propagation is compression ratio. Higher the compression ratio, higher the pressure and temperature, which results in reduction of the amount of residual gases, therefore enhancing flame propagation. The third parameter affecting flame propagation is intake TNP. Higher the intake temperature and pressure, higher will be the rate of flame propagation, resulting in better engine characteristic. The fourth parameter that affects flame propagation is engine load. With the increase in engine load, the cycle pressure increases. Due to this increase in cycle pressure, the temperature increases, resulting in increase in flame propagation and therefore imparting better uh, engine characteristics and performance. Another factor affecting flame propagation is turbulence. Flame velocity increases with increasing turbulence mainly due to two reasons. These two reasons are, first of all, with increase in turbulence, the rate of heat transfer increases due to increased area of contact due to increased area of contact. Another reason is that diffusion of burned and unburned portion of the flame front is taking place at a faster rate and hence flame propagation gets enhanced. Turbulence in a SI engine will occur due to admission of air fuel mixture through narrow pipes in the combustion chamber during suction stroke. Insufficient turbulence will result in low efficiency. Another parameter that affects in flame propagation is engine speed. Higher the engine speed, higher the turbulence. Therefore, the flame velocity, that is the rate of flame propagation, linearly increases with increasing engine speed. The last factor or engine variable which affects flame propagation is engine size. Engines of similar design run at the same piston speed. Therefore, irrespective of the size, all the other parameters such as degree of turbulence, flame speed, etc. are same. Therefore, flame propagation is unaffected due to variation in size between different due to variation in size of similarly designed engines. This is Now I can conclude that flame propagation is a very important parameter in determining the engine performance, and there are several engine variables upon which affect the performance of an engine through flame propagation. Thank you for watching this video. I hope it was helpful.